this is the week 3 overview video. And it's going to be a little longer because there's a whole bunch I want to talk about, but I thought I would start with showing what I am submitting for my week 3 entry and why. First, up on the screen, see here if I can point correctly based on the Zoom, you see some curtains. So if you remember my week, was that 1 or 2? Where I guess that would be the only choices, Eric, 1, 2, or 3. It's not 3, so it'd have to be 1 or 2. Sadly, I can't remember what happened 2 weeks ago because so much has changed. However, I had a stretch goal in one of the submissions, which was like, I want curtains to open, right? Pure CSS and go from there. This time in this submission, it's using a HTML5 canvas. And if you notice, we have these little tentacles, and we'll highlight them here on the page here, because we're going to open the curtain with the tentacles, right? So let me switch off my annotation tool. Bam.
Ahoy, brave navigator. You are Nemo, a young pirate who learns the secrets of artificial intelligence by
Now I'm hoping the audio is coming
exploring
through a little
mysterious
bit,
islands.
right?
Place
We're not going to
concepts
listen to
in
all this.
blocks.
Almost skip ahead for a minute. So I was experimenting with I didn't have enough time to. So just spoiler alert, I did not build from scratch 80 style text to speech voice engine. I got the hooks for it. And then I realized like, I don't really want to build test cases for this. This is like a whole sub module and I don't have time for that. But it turns out, and I didn't realize this, that all the modern browsers have text to speech built in to the DOM, which was a big surprise for me. Like, oh, you can actually just use a browser for text to speech, and that's just baked in, which was kind of mind blowing to me. So on a few of these different, not inside the game itself, but on a few of the buttons, even it will actually say, okay, this is what's going on. And this game is crazy because there's so many different options. For example, there's a bestiary.
Bestiary.
And inside there's different characters. And if you click on characters, you can go to threats and you can see the flora. So it even has all the different types of stuff. And you'll notice here that there's a little filter at the top. That's because this has DLC. I think we ended up with, I say we, myself and team of agents, I think we ended up with 4 DLC. There's the first one, second, well, now I'm just counting, right? Okay, I think we can all count. But effectively, there's one about rockets, one about cybersecurity. There's the base game, and then there's this gauntlet mode, which is I'm going to show that here in a moment because it's just bananas. We also have ground tiles, so you can explore that. But if you click on, say, Fire Crab, you can hear a narration from the
Danger 3 out of 5.
text to speech engine talking, right? Like I don't know if the audio is coming through, so I'm not going to like sit here and try to listen to it with you. But I think it's really interesting. It's like, oh, I had not intended this week to be about audio. Maybe week 4 might be something about audio. So if you're watching this video, pro tip, we might be doing some more audio stuff because turns out the modern browsers have a lot of interesting audio capabilities that I think collectively everyone's been thinking about AI, but it's like, you know what? Browsers have some interesting features that I don't think people have really leaned in on. So maybe we'll figure out AI and audio in some more sort of way. Okay, so there's a leaderboard that uses SQLite as a storage mechanism on the back end. Again, I didn't write any of this code. The SQLite was, I think one of the Claude agents actually ended up putting that in place for me. Kira ended up having to do some adjustments. And then, yeah, so you have a whole leaderboard. Different score capabilities. Right now you can see I've got a few points on the board. And then there's play. So on the play side, there's memory C, there's starboard launch, there's cipher C, and then there's the gauntlet. Now, the memory C is based on what both Kyle and Myles had submitted here this week. And that's how you know I've done this pretty quick because it's Sunday morning-ish. And they had provided their submission towards Friday. So I took those and then actually went and picked up Evan we had some conversations because we had some errands to do. We actually had been out. So I was able to do most of this also while not at home. So this has been just a thing that I've been doing while not even at the PC. But we kind of talk through like, how does this work? And then I'll come back up, show Gauntlet, and then I'll start breaking down all the different components. And then if all goes well, I will also be showing a presentation from Notebook LM, which I'll figure out After Effects slice that into this video, probably towards the end. Okay, Memory C. So the idea for this week was learning with AI learning. It's like using AI learning systems, and one of the examples was the methodology with or loci, which is this. It's the memory palace technique, right? So you can, if you walk around, you generally know where things are at. For example, if I asked you where the dinner plates were at in your house, you immediately know where they're at, right? You just know. So you can use that to stash information that maybe isn't a dinner plate. And it's ridiculously effective. I use it periodically to just learn just different topics. And I find it's really interesting because you'd be surprised when a random topic will suddenly add value. But the key is you got to have time to like work with the meat sack that is your brain and all the brain chemistry to actually learn and recall those things. So it does take some effort. So if you click set sail, you're gonna notice there's some rain clouds, some lightning. We're going around. Gotta wait for a minute. Now it won't show because I'd have to play through the entire game, but there is a Kraken that's fully puppeteered that shows up. Now this game also has a cinematics engine. Some of the cinematic screens are clearly not great because, as you can see here, we have a gap here that I didn't bother to fix. Overall, the water is pretty good. There's some nice bubbles that go across it. There's a nice little kind of 8-bit call out for, the text down here. You can see our main hero, Nemo, and his parrot. Parrot is supposed to be perched on the shoulder, but isn't. And then you have like this, again, we're just going through the story piece here. Okay, now we have like the main game stage for this memory palace technique. So you can wander with arrow keys, or you can tap on the phone to navigate your character to pick up these power-ups. Now you'll note that eventually this little hint line shows up. It's like, okay, you're supposed to come down here and do something. When you do, it shows up a learn. So you click on learn. It's going to ask you, it's going to tell you a little bit and says, hey, I want to teach you something, blah, blah, blah. We're learning about AI techniques on this one. So I'm not going to like read through and tell you what the answers are. I just have played through it a few times, so I know. And then, okay. Now you'll notice down here, we've got these little things I can drag. And if you drag that to here, that's an intentional action. And it's intentional for a reason I'll show you here in a minute. So we're going to do this next one. We're going to say, after saying, go ahead, just the captain draws the chart. What do you call the pattern a machine builds from training data? It's a model, right? So we're going to click next. We're going to click next again. And now we're going to tap pairs. So it's not single answer on these. Some of these have like different choices. Sometimes you have to answer in batches, right? And it's like an interactive learning adventure, which is more like Kyle's approach, which I really liked because I did that with the Spring and AI article. I was really surprised at how well that did, was just taking a random article that I pulled off the internet, which was the Spring and AI competition rules. And it built out a whole course. I was like, wow, this is super cool. Like, what else could you do with that, right? It's like, well, what if you somehow combine that with the memory palace technique in a video game? What would you get, right? And so that's effectively what I try to do here anyways. Now, there's a bunch of UI HUD stuff. I'll come back to that here in a moment. We're going to finish the third one. We're loading the canon, training model, blah, 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 prediction on new data. And of course, the answer is inference. Inference is using your model to make predictions, right? So here we go. I'm going to click that. Question is, the cannon sees a new shape. What will the model predict? And the answer is, chip is the enemy. Direct hit, right? Training loads the cannon with knowledge. Inference pulls the trigger. Well, let's hope less triggers with AI systems with more knowledge. Okay, so we're going to drag that up to here. I completed the map. Now you'll notice like there's this like countdown timer coming down. You got to tap to recall when it asks you in the lower right what the challenge is. Where did you stuff that information at, right? And so it times you based on different scoring mechanisms. And I got a grade A because I was trying to explain. You can get grade S is like S tier, and then you can click continue. You see these little orbs down here as you continue to go through and collect these different knowledge sectors. So you can see we got a tentacle now. We have one tentacle. It gets way more interesting as you get all the way to the end because you have a Kraken boss fight to do. But, you know, for this video, it'll be probably another 30 minutes of me just trying to play through the game. So I'm not going to put you all through that. You can hit the URL if you want to try it yourself. I'm going to refresh the page so I can come back to the main page. I just love the tentacle pulling in the game curtain. I just think that's the coolest thing. So you come to play. So as you go up the ladder of difficulty for the memory palace, you go into some of the DLC. I ended up adding some enemies that you could do like a small combat routine on. And the combat routine started out first was like it was a prompt of like you going through the memory cards again. I was like, that's kind of boring. I was like, what if it's more like a Pokemon battle game? Like, and I started thinking to myself, oh, that would be hilarious. Can I put a whole Pokemon game inside of this? So there is a mix of a Pokemon game slash pirate adventure slash learning thing, but also just want to note, you might have seen it. I'm going to do a couple more navigations. Did you see how the tentacles come out, pick up the character, and then drop it? So let's do that again. We're going to come over to the side. Bam, you know, tentacles came out, character gets dropped, and gets dropped into place, right? So the trick to this was working with one of the agents to build a puppeteering system. So when you go look at the code, you're going to find like a puppeteering system that it knows how to use. Like I have no idea how it works. I have not looked at the code. I just know it exists. And I was like, that's how we do the curtains. And I was like, oh, well, if we can do the curtains, what else can we do with that? I was like, oh, there's a few other things in that. Like, oh, it'd be kind of fun. Like as you do the Zelda, you know, navigation between the different zone transitions, you could just pick up a character and put them down, right? Like that would be so cool. Now, there's trees, there's a whole bunch of different enemies. It's an endless roguelike, which means that a few things. So first, we're going to trigger a combat scene. So here we have a crab. We've got charge, defense, and attack. We're going to defeat the crab. Okay, I've got some points. Notice my SK went up. So I'm going to tap or click the SK. You have a skill tree. So with the skill tree, you can come in here and you can do some upgrades. Like, look, my mind is blown. I worked on this while literally I was out of the state on my phone. Okay, so this is a little mind blowing to me. And I did use a couple techniques, which I'll talk about. Like I did start out with a good solid base, and then I did have some prompt stacking I wrote a little bit about on Substack. But it's just amazing to me that you can just kind of whip something like this out. But it's not just a game, right? I love the tentacle explosion things. And these power-ups all do something like that. Power-up causes people to stay in place. It's like a frozen one. We're going to move around some more here. Actually, I don't know what the charge one does. Oh, it moves them. Looks like it gives them a shield or something. Different types of enemies. What goes up? Crimson Mall. So apparently there are named locations. I didn't realize that. And borrowers that must come up out of the ground. So let's see if we can defeat them. Okay, looks like, okay, so I'm getting a nice small upgrade my attack here. So I just think this is amazing. Okay, actually, I don't know what this button does. Oh, it takes me back to the main. Okay, so if you click that, game's over apparently. So be careful what you click. Starboard launch. I'll just show this. It's the same sort of thing. There's a reason why there's the lightning and whatnot, because you're gonna, but you know, as you go through the stages, you get tentacles coming up, and then eventually there's the Kraken that emerges. Again, the cinematic cutscenes, but now we have a rocket ship. Now I recognize the rocket ship might be hard to see, so we'll draw a circle around it. It's right there. There is the rocket ship, so you can see that. I'm learning to record a video with the tools, the editing tools. We'll see. Hopefully those come through. Otherwise, this is going to be, you know, it's already probably a goofy video, but then on top of that, it's going to be weird because I'll be talking about, oh, I drew a circle around the rocket and you don't get to see it. Having said that, we will continue on our journey, and you can see that we've got some enemies here. We've got this purple spike thing. Oh, it just got attacked by some ground worm. We'll have to defeat that guy real fast. but it combines the combat mechanic with the learning, and that's the idea with the DLC. Like, it just progressively gets more difficult with different concepts. And then again, that's what gave rise to the idea of like a roguelike with this Pokemon skill based system where you could explore an endless terrain system just with enemies, and you can go as long as you want, right? And ideally, the further into the map you go, the enemies get harder, progressively more difficult. But there's some other things hidden inside this thing. There's really almost too much. Okay, I say that because if you click about, this comes with a whole marketing subsite. So here we have the main character, Nemo, the stochastic parrot that sits on his shoulders. It's got this kind of cyberpunk, no, more like steampunk, cyber steampunk, cyber Pirates of the Caribbean. I'm not sure what to call it. I'm sure there's an actual name for this art style. I'm not sure what it's called, but it's kind of cool. You can see in the background the blocks are pixelated, and the captain and the pirate ship is there. There's a whole bunch of content down below, which I won't jump through, but I'll just note that you can click on gameplay and you can see our captain, Nemo, loading up his AI tokens. You have to go on characters. You can explore some of the different characters that are in here, encounters, same sort of thing, islands, so on and so forth. A lot of the art is really good. What I'll note is that you'll note that there's character consistency. So if you look at the characters, it's not perfect, but it's pretty good. Green parrot, facial features are largely the same for the pirate captain. So as is the uniform blocks. So you end up with a fairly uniform looking. I think there's another, if I scroll down here, we can see yet one more down below of this character. Here we go. This is apparently there's an underwater scene somewhere in this game I haven't found, the hidden reef. So if you happen to find the hidden reef, let me know. It's somewhere in this thing. And then these different islands that are available, which I don't actually know if those are all in there or if it's just concept art that the AI came up with. There's a whole DLC subsection, so you can go see the DLC that was included inside of this thing too. So there were no pre-orders. So everybody gets all the DLC and all the wonders of this game that was built over this weekend. There's not much of a cyberpunk rocket ship stage. Maybe there should be. Maybe some of the tiles could be a little cooler, but you can download the code for yourself. So I think that's pretty amazing. One last thing. Got the tentacles to open up, right? Okay. Let me talk about what is a little different with this one and how that translated to what I was. I'll start loading that up now, but I need to first go to GitHub and pull up some information. So when I picked up Evan, I was talking to him about his submission for the week. And I said, hey, I have an idea for you, which is based on, and I saw Kyle had just posted something on Substack about this. I will attempt to put a link to what Kyle just wrote in the description about the audio system and the browser and some of its capabilities. But I want to talk about a concept that's running as an experiment with Evan, and it worked out pretty well. And then that's what I used to jumpstart for me. So the background behind this is that, and I have a fork of it in my Arc Builder repo, which is there's a product management skill set you can download for an OpenClaw agent, right? Or many agent, frankly, that teaches your agentic AI system product management capabilities. And I was reading through the list, and they're pretty good. And I was kind of going through it. It's like, wow, that's pretty impressive. So I ended up forking that, and then I used that to base out like, well, what if there were engineering ones, right? Using common engineering approaches and skill sets. Like, that's not public. That's just one I have for myself. And it just walks through all the common like engineering use cases that exist. I don't have mine public because one, I think there's a matter of taste in there. Two, it's not really proven out. I don't know if I necessarily want to maintain it. So further, I just know the internet. Someone's going to come up with a better version if I wait just a little bit longer. So I'll just pull that in when I need it. But I may not have to. And the reason why is because of this knowledge concept. So if you go into Evan's knowledge section here, you're going to see these different markdown files. Now, what's interesting is that um, he used the Opus 4.6 model in GitHub Copilot to lay out all these files. He has an agents file down here, somewhere in here. I thought he had he may not have put an architecture file in here. He has a web architecture file. Pull that up for a minute. That talks through the game stack, the files, what looks like a Unity style scene management approach, right? You get the scene editor, all that. Just as an aside, I don't know how, when you can just vibe code your own game engines, I really wonder how some of these bigger game engines stick around. But that's an aside. So there's lots of content here. I'm not so much interested in the specifics. I want to talk about the broad stuff. So there's these knowledge files, right? And so when you build out a project, you typically think about having different markdown files for like, I need something for my agents MD. I may have some skill files that connect into supporting resources. For example, you may have something that like you saw with the website here. Oops, am I sharing all the tabs or am I only sharing part of the tabs? Let's find out. I am sharing all the tabs. So here, this image, right? When Kira uses her Gemini Nano Banana skill, she's able to pair that with her agentic coding skills to generate an image, pull it down, put it in the correct place, edit the code, commit the code, publish the code to GitHub, and at the same time, do a deployment with a CI/CD pipeline to get it live in production, right? One full circle. So that's a really good loop, but that's more like an operational task, right? But what about like, how do you do good art, right? What's the trick to doing good art? What's your art direction, right? So there's this markdown file that Evan has in his project. You can see it's owned by Claude, and it talks through like what the visual direction is, what the assets should be named, thinking that, well, maybe there'll be PNGs in his project. There were not. Evan ended up going in a different direction, which was, and this is just an aside, but he ended up going in more of a procedural asset direction. So the audio is procedurally generated, the art is procedurally generated. And so the AI created an AI system to procedurally generate all the assets required, right? And that's pretty much how the Stochastic Parrot or Dead Reckoning adventure fire game I'm submitting this week also worked, which is pretty interesting, I think. So you have these different, there is a plan. Oh, it's in the plans folder. That's right. So he has some plans. I think, oh, that's right. So he started with a plans folder and then it broke into knowledge. So first he started out with the plans folder with this architecture overview, a doc plan, a game build plan, kind of just high level plans. And then the theory is like, okay, once you have your high level plan, what is the knowledge required to really be effective at executing your vision, right? So it's more of, it's like a, I don't even know what kind of workflow this is, but it's, you have like an intent that you're planting a flag at, you know where you need to get to, you have the broad bones of an architecture and approach for building the thing. Now you need a set of skills, right? It's like you're hiring a team, right? So you got to go hire, I don't know, contractors, consultants, you have employees within an organization. You got to start team building to figure out like, okay, who can I bring in? What kind of skills do they have? What would be the most effective pile in order to deliver, you know, my vision? And it turns out you can just do all that with AI these days. And so that plan feeds into the knowledge section here, right? And the prompt is pretty simple with AI. It's like, hey, using the plan, build out all the knowledge files to ensure that we are going to build like the best version of said product. And you can use the plan mode in Copilot to figure out what all kind of questions you need to answer, and then swap it to agent mode, and it will just go through and write out your plans. So that approach is what I ended up doing, something very similar to that, just at a different scale, right? So what I ended up doing, let me stop share for a minute. Let me swap over now to the right repo. So I ended up doing a very similar approach on a slightly different track of theory, which is like, okay, what if it's not just like a couple markdown files, which is typically what you see in these kind of projects. You'll see like, there's an agents MD or an architecture MD for harness engineering, or there's a, as you saw with Evan's example, maybe you have a few examples of like See if I can find the knowledge file here. Okay. What if instead of doing it just at like a high level, you just like provided an entire college education inside your repository, right? So let's pull this up so I can create some more. So there's product management, which these are used for the website content. Then you have this knowledge folder in this repo. You see there's a template, there's different there's effectively lots of different files in here, right? And the purpose of this is, here is my thinking. My thinking was like, well, if I create these markdown files, what I've noticed with the AI coding tools I've been using is like there's always a gather step where it's doing like a text search, right? And it's searching the code base for relevant documentation about what it needs to do or the patterns it needs to use. And so when you're doing something new, typically you don't have any of that because it's a brand new repo. It doesn't have established documentation about how it needs to work or whatnot. So what if you flip it? What if you go, okay, well, if it doesn't exist yet, what if we just use AI to drive all the education we need and have it build out all these different markdown files, including, for example, if I pull down, there's even game design in here. There's some stuff about the product itself, some telemetry and standards. I couldn't tell you how much of this is actually in the final product, but I could tell you that what it seems to have done is created a much better base with which the code could work, because clearly the game has, it's probably in terms of like a quick 2-day vibe coded product, it's the most complete thing I've done game wise. I've done a ton of vibe coded like apps and games, but nothing quite to this level so quickly. And I attribute a lot of that to all these different files because I think it provided some domain knowledge. There's even like this whole design aspect you can look through. I encourage you to poke through. You can see that the original character is no longer called Nemo. It was supposed to be called Rex or Vex, which I think is interesting because Vex appears a lot in the Claude latent space for names. That's a whole other thing, but it's interesting that that character even appears here. There's a README. Oh, there's also this. So this is a giant block of text. And you may wonder, like, well, what is that? It's like, well, you could take this and drop it in chat GPT and get an answer, but I'll tell you what it is. When you look at the week 3 competition release, I had mentioned like, hey, level 1 of Super Mario Brothers for the original Nintendo Entertainment System is like considered the gold standard of education, tutorials, everything when it comes to a master class in interactive education, right? Because you learn how to jump, you learn what the power-ups are, it's psychologically safe, it's got, barriers, and you learn the entire game in one level. And so I use Google's deep research to go deep research how you do that, right? What's the approach for you to go through and build out games that make use of some of those principles? And so there's a bunch of content here, and I am not going to pretend that I read any of it. I just dropped it in and just told the AI, like, hey, make sure you make use of the design, knowledge, and product management folders while you're going through and building things. So the architecture MD talks through like all the different stack and kind of what's in there. And you can see here, it's like got all the stuff. It's got the configs. It's got a get ignore. There's some source. I am not going to go through every line of code in here for you today, but you can see, oh, I guess it did include a telemetry system in here. How's that look for the eventing? Oh, wow. We built out a whole event. This is pretty amazing. All the telemetry events are nicely tagged. The other really neat thing about this project is that there's almost, I think there's like 4,700 some odd tests. So you can come in here and there are so many. Where are they all at? They're somewhere, I think they're here. Oh, here you go. Every different component of this game has a test around it, right? So the audio system has it, the core system has it, the scene management system has it. What, 5,000? I was trying to figure out if I had to write 5,000 tests by hand, how many decades would it take? It takes me a long time. There's no way I'd still be writing tests. But what was nice about it is I would often find myself in a flow of like stacking prompts And then I would be like, okay, I know it's going to have some problems. So I was like, okay, after about 3 or 4 prompts of like stacked prompts inside a Copilot, I'd be like, okay, now add some unit tests to ensure that all the stuff you just added is going to work. And then and then I would just kind of continue peeling from there. And then eventually I would go in and provide some human directed feedback like, okay, this is kind of working or this is not working, um, because the AI just couldn't figure out like visually how things needed to work. I suspect that the newer models will probably solve a lot of these kind of problems. Okay, so that's that's an overview of the code base. I guess I should probably note a few other things. You can come down here. There's this README that talks through like how to actually build things, the project structure, and SQL runtime notes. So yeah, it actually has a database. You want to check that out and play around with it, you can go to URL. See what else was I going to talk about with this. I think that's the gist. The big experiment here was really taking and injecting this new idea of like packing in expertise via markdown files to activate concepts within the model while it's doing the construction of writing the code. Okay. Hopefully you understand what I just said, but just to back up for a minute, the way these AI models work, right? When you provide tokens, it activates different connections within the neural network. So you can imagine now if that's how that works, and if it's the case that by providing these markdown files that explain these different concepts and those tokens get injected into the process of the model as it's reasoning through trying to solve a problem, it's going to activate on things like game design and core game loops and mechanics or eventing systems or telemetry hooks and input controls. Meanwhile, you're just sitting back and sipping a coffee, as it were, which is pretty wild. So now I don't know. We're going to see if it's done yet. Let me pull that up here one moment as I pull up the next thing to talk through. I'll see if it comes up or not. So in Notebook LM, I fed in, oh, here we go. Looks like we've got something. Let's see if it's done. I'm clicking, but nothing's happening, Google. Why is nothing happening? Oh, okay. So we can. Perfect. There is a slide deck, which means I can start the slideshow. Oh my gosh, this is amazing. Okay. So Notebook LM, if you're watching this, and there's a small crowd of folks that watch it. So Notebook LM can do lots of amazing things, lots of different content, including making sense of code bases, right? So for example, let's share the screen one more time. Sharing the screen. Where's my annotation tools? Turn on annotation. There we go. All right. So Notebook LM made this while I was talking on the video. So this is as real time as it gets. I actually haven't read through this presentation yet, so hopefully it's reasonably correct. But yeah, so we have what looks like a peanut, which would be about the size of my brain. And out of that peanut or seed grew all these different components. And so it's building a full stack educational game by seeding the AI latent space. And I have posted on Substack this idea that when you start thinking of the software this way, you can't help but feel like you're a gardener in the latent space because you're planting seeds, knowing that once you plant the seeds, then there will be AI models that come around, pick up those tokens, activate upon those tokens in order to then generate the code to get to an outcome, right? And then the way that you direct and ensure that's going to get towards the outcome you want and start adding unit tests or some sort of evaluation steps or scripts that you can ensure that the outcome is moving generally in the direction you want, right? You're kind of coaching multiple AI systems in a certain direction. It's not like training a dog, frankly. So here we go. Building a complete application requires seeding the latent space first. That's a bold claim. I don't think you need to, right? You can go vibe code a very simple app today by just typing in a small prompt. But if you go into a lot of these vibe coding tools, V0, Bolt, Replit, what have you, and you provide a screenshot or you provide, say, I don't know, an extract from another system, like when you do that and you provide it to these builder tools, what's actually happening? Well, these systems are looking at all the content, they're picking it up, and they're trying to make sense of like what code to activate upon. And then from that, it gets you to higher quality output, right? And my claim here is that if you look at what I did with the Um, Stochastic Parrot it actually has a real name. I think it's called Dead Reckoning. I don't even know what the name of it is. I don't know the story fully. Kind of played through it enough to sort of know, but click, 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 trying to get it out the door. So someone out there is going to actually play this thing and be like, "Hey, my story is fantastic," and be like, "Oh, that's great to hear. I'm glad you enjoyed it." Uh, I've talked through this process, but just to highlight it again, you take your folder structure, you lay it out with all, not just the architectural system bits that you intentionally put in, the seeds of knowledge required to build out the application, right? And then from that, the code generators start working. They take a look at the project. They start expanding, building out some things. Then you get a whole game of marketing site. I thought about connecting this to Agent Wardrobe, but then I was like, well, you know, I actually have stuff I need to do today. I've got some groceries I need to go pick up. I've got some cooking to do. I've got some kids to run around. I don't think I also have time to do all that and make sure it all kind of fits together and do the video required and whatnot. So you can do a lot with AI, but yeah, also know your limits, right? And I think 2 days is pretty good for this thing. I shouldn't even say 2 days. Maybe it's like 24 hours. Providing education before generating code changes the output paradigm. Oh, so this is a fantastic slide. Just thinking of the slide quality here, like without, too much, like this is pretty good. Like traditional workflow, it's exactly what I was just saying, right? So Google has picked up on what I was saying. You have the traditional workflow, you have a prompt, you have a code output, you have endless debugging. Let's be real, you have endless prompting is probably the better word. I don't think these days, I don't debug as much as I usually do. I just have an argument with the AI about what the output should be. The stochastic parrot workflow provides like a baseline of education with all this context, right? And then that grounds the AI in towards the outcome, and then you get this cohesive application output that's just massive, right? You can see just the sheer amount of code that's produced, both with mine and also with Evan's. The gathering phase, again, I had mentioned this, but just to repeat that step, it pulls in the AI's content during this gathering process. So what's actually happening there is the tool harness that writes the code, right? It has these like search capabilities within your project workspace. And this is true for Claude Code, for Cursor, for VS Code. I would assume Windsurf and the new one from Google, that they all work the same sort of way, right? Like they still have to go look into your project to see what the content is, and of that content, what matches back to answer your prompt in order to build the code, right? What I'm doing is hacking into that, kind of splicing the wire to inject a whole bunch of understanding about like what the project is all about in order to deliver a much higher fidelity outcome. We've got the product management documents. This is going to look a lot like harness engineering. Harness engineering is its own thing, but what I'll just note that is like, if you look into harness engineering and agents MD and architecture MD, you're going to find two camps. You're going to find camps, people who say it doesn't really do much. And then there's other camps where it's like, look, I just built a whole working app in a couple hours. So surely there's something to it. I think it just depends, right, on what you're trying to do. If it's brown field, if it's blue field, or if it's green field, or if it's whatever color field it is, it just depends. And so having a sense of like what outcome are you trying to get to is the most important part of that. But here you can see this whole flow. And again, I'm learning these slides with you as we go through this PowerPoint together, but gathered knowledge is injected into multiple coding models to generate cohesive outputs, which is exactly what I was saying. Now you'll notice it says parallel coding models. Something Evan and I both did was not just run an initial battery of one coding model on the task, right? I have this theory of you first seed the workspace with all the different contexts you need, right? Then the next thing you do is you get a prompt structured that's largely safe to run with multiple agents at the same time. And then you fire up like 12 of these bad boys and just have them start cranking through code. Now, someone's going to raise their hand and be like, well, Eric, if you do that, there's going to be a lot of waste. There's going to be code duplication. There's going to be files that get added that shouldn't be added. And you're absolutely right. I don't care because the code is free, right? It used to be a problem, like when I cared about the code and like, it was costly to produce. But now that's effectively free, or the cost of, inference tokens, or effectively the cost of electricity, like it doesn't really matter. Like instead of just plant first your seeds, go wide, and then once you go wide, come back with the cleaning path to bring it together, and then narrow from there, right? And that's what you're seeing with this flow here. Um, Grounded beliefs, navigate, determinant. Man, I tell you what, I think AI should probably just start giving the presentations at this point. And maybe it will. Maybe we'll see what the video looks like, and I'll pop that on the screen, and we'll see how that goes. But this is a great slide: deterministic chaos, source ground beliefs. So I think all this context actually does act as a filter, right? I think if you think about how I've been describing it, it is somewhat of a filter or shaping mechanism. I like to think sometimes that working with the latent space is a coding exercise, but I'm sorry, it's more like using pottery in that sort of way. Oh, hold on a minute. I gotta shut the door. My dog has come in here. Oh, okay. So next we have, let's see. The foundation. So if you look at the codex prompt, you're going to see like it's got some foundational items that all these different parallel agents jammed into place, right? Which was what you see on the screen. It's like getting all the key components laid out. I just had multiple of these prompts running at the same time and went with whoever got to commit in first one, right? That simple. Like sometimes it was the first agent I started with, sometimes not. Ultimately, like I said, it doesn't really matter because code's free. So just fire hose as much as you want until you get the outcome you want, and just it reminds me of my great grandfather used to whittle wood. He was when he had retired, he had spent a lot of time just making different kind of wood structures. He made me a wood toy car. There's just different types of wood creations that he would make, just with his hand, just carving the wood. And software is kind of in a weird way turning back into that, where you're shaping, not quite with your proverbial hand, but I could see a world very clearly where you could shape code just by directing it with hands and some voice commands. So again, you get out of this fully working code base. It looks like we ended up with Vite. We're using some Playwright and Express API. I haven't looked at any of the code. So if you look at the code and actually like spend time reading through how it works, you probably know more about it than I do. AI generated fallback logic ensures runtime resilience for the SQLite database. Oh, so we apparently have engineered a really good persistent model for the SQLite database. I don't know exactly how it performs that. I'm sure I trust the AI that it probably is at least an approach, and it's good enough for this app. It's not like there's going to be thousands of people on this thing. Let's be real, be lucky to get 10. So it's cool. Let's see what else. Deployment run book. Oh, the deployment run book is useful. It's actually more useful for me because Kira handles all the deployments. So Kira stuff the domains, the PM2, manages the whole ecosystem. And I don't have it, it won't be in here because Google won't know about this, but it was actually an interesting exercise having multiple autonomous agents contributing to different parts of the project while at the same time I had Copilot working on the code, right? That was a really interesting balance. And I was fortunate that it's a short month, so I ran out of tokens and was able to finish it up this morning, right? So I would love to see getting myself to like maybe a 1,000 agents, but I don't know how to solve the token problem. Like, how do I get all the inference tokens required? So I'm eyeballing a rack next to me thinking, how do I get some more tokens locally that I can just have more agents spun up? I just can't seem to get enough of these things. Fallback logic for the database, that's good. More software architecture stuff. Come down here. Oh, what an awesome art style. That's not the official art style for the game, but man, that would be a cool art style to build a sequel to. Maybe I will. Maybe I won't. Okay. I think is that the end slide? Oh, modular architecture. Oh, of course. So I talked about this. The game features a DLC solution, so you can expand modules on it. So if you want to take the game engine and add on 12 DLC, just submit a PR request, and I'm sure I'll have one of the agents take a look at it. And if it looks good, then we'll merge it in. Sounds good. more latent seeds going in here. Okay. Last slide here. Combining robust knowledge, gathering, multimodal execution yields productive software. I think that's the most important learning I've had. I'm so glad I did the spring and AI competition because it's allowed me to experiment with different techniques. And one of those is learning this one, right? It's like, oh, well, wait a minute. What if I approach it this way because of what I've been seeing the other guys do? And it just inspired me to do it in a very specific kind of way. And it's like, holy crap, this works really well. So that is the end of that. Now let's pause this for a moment. I'm gonna see if I can do it. And when I say that, there's a video that was apparently produced. We're gonna see. All right, we're gonna try it. I'm gonna try it. Share here. Here we go. Hopefully the audio comes across, or this will be the most awkward section of the entire YouTube stream today. Let's see, share. 5 minutes. Here we go.
All right, so today we're going to set sail on a pretty different kind of sea, the digital ocean of AI development. We're charting a course through this really fascinating project called Stochastic Parrot. And it's not just some quirky game. It might actually be a treasure map for a whole new way of building software with AI. So yeah, let's weigh anchor and see what we can find. And you just know this journey is going to be different from the second you land on its GitHub page. I mean, come on, this isn't your typical dry technical README. It's an invitation to an adventure. This one line immediately sets the stage for a project that's as playful as it is, well, profound.
Who wrote that?
So what is this thing really? What's the deal with the pirate theme? Well, on the surface, Stochastic Parrot is a fully playable browser game. It's called Dead Reckoning Memory C. And it's built with a really modern, robust stack of web technologies, which makes it way more than just a simple experiment.
And
I'm serious, this is not just a little script. Under the hood, this is a complete production-ready application. We're talking a Vite client, an Express backend, SQLite for persistence, and even a proper Nginx and PM2 deployment setup. This solid foundation is super important because the project is trying to solve a very, very real-world problem. And that problem is something I bet a lot of you watching are facing right now. We all know AI is amazing at spitting out little snippets of code, right? But how do you get it to build an entire, cohesive application from scratch?
Wow.
Now that is the real challenge. This is the developer's dilemma. You've got a brilliant idea. You fire up an AI, you give it a prompt, and boom, you get some code. You prompt it again, you get a little more. But how in the world do you connect all those scattered pieces into a stable, well-architected system? Usually the result is, well, it's chaos.
Yeah,
it's this tangled mess of functions and files that kind of work on their own, but they lack any kind of unified structure.
Cool picture.
It's like having a giant pile of ship parts, but absolutely no blueprint to build the vessel. This project, though, it offers a fascinating way out. And this right here is where we uncover the real treasure. See, the core innovation of Stochastic Parrot isn't really in the code itself, but in what happened before a single line of code was even written. It's this idea that's captured so perfectly in one little commit message. This one line is the central idea of the entire project. This commit message for a new knowledge folder proposes a really radical shift. Instead of just asking an AI to write code for us, what if we teach it the concepts and the architecture first? So, this is the crucial concept the project introduces, knowledge seeding. It's all about front-loading the critical thinking. You write these detailed markdown files explaining the architecture, the different software agents, the deployment plan. You're basically creating the project's DNA before a single component even exists. And this just brilliantly illustrates the proof. I mean, if you actually look at the repository's history, the knowledge folder and these key architecture documents were the very first things created.
Yep.
They are the pre-code build, the treasure map laid out for an AI to follow. Okay, so how does this map lead to the final treasure, a working application? Well, the process is just as elegant as the idea itself. It's a workflow that puts the human in the role of the architect and the AI in the role of the builder. It really breaks down into 3 simple steps. First, you document the knowledge. You create that master plan. Second, you feed that plan to the AI and have it generate the entire project skeleton, all the folders, the boilerplate code, the config files. And then third, the human developer steps back in to refine, build, and add the complex logic on top of that solid foundation. And the result is a direct translation of the plan. the architecture MD file, which describes the game client that seeds the creation of the SRC folder. The agents MD file, outlining the backend, maps directly to the server directory. It's this clear one-to-one translation from a human-readable plan to machine-executable code, all facilitated by the AI. It's so cool.
So, what does this all mean? Why is this pirate-themed game so much more than just a novelty? Well, because it offers us a new compass for navigating the future of software development.
The huge takeaway here is this fundamental shift in thinking. We're moving away from treating AI as a simple code completion tool that we just prompt for little snippets. Instead, we're treating it like a collaborator, one that we need to educate, to bring up to speed on the project's vision before we even ask it to contribute. And this approach is just so powerful. It leads to better structured apps because the AI has the full context from day one. It redefines the developer's role to be more about high-level architecture and, teaching. And most importantly, it gives us a repeatable strategy. And then, in this beautiful recursive loop, the project itself is an educational game that teaches the very concepts that were used to teach the AI that built it. Which, of course, leaves us with a final, pretty thought-provoking question. If an AI can reliably build complex applications from a well-structured set of knowledge, does the future of programming look less like lines of code and more like a well-written lesson plan? It really seems like the treasure map from this project might be leading all of us to that very conclusion.
Unbelievable, my friends. Unbelievable. So I would like to say I did anything more than click a button and give some direction, but apparently it's just the strength of the idea and everything else just followed naturally. So you've seen the pitch, you've seen the complete overview, and I've gone through this whole process. Hopefully you find that of use. If you innovate on this yourself, please let me know. And otherwise, I need to start preparing to figure out what we're doing for week 4. So until then, ciao.